Okay. So the last couple days in math, what we've been dealing with is we've been dealing with vertex form. And vertex form is really valuable to us in the sense that it shows us where our vertex is. And it also makes it really easy to predict things like how many y-intercepts there are, how many x-intercepts there are. We looked at that case where there's either 2, 0, or 1 x-intercepts. And we can tell that solely based on the vertex. We also looked at writing out equations for graphs, saying that hey, that's even easier too if we also know what the vertex would be of this graph. So now what we're going to do is we're going to start converting those vertex form graphs into standard form. And standard form looks like the following: it looks like y equals ax squared plus bx plus c. And we can find out all the same amount of information about parabolas from equations in this form. We can figure out the direction of opening, we can figure out the intercepts, we can figure out the vertex, etc. But the process for actually finding out those pieces of information is different. And so we're going to use a table of values here to sketch out the graph of the following function in this first step here. And then we're going to talk about how the manner in which we're calculating um, the x-intercepts and so on and so forth, or the vertexes. We'll discuss how that is different. So we were told that we want to calculate out a table of values. Now, what I'd like to do first is before I actually get into any of that piece of information, the first thing I'd like to decide is, okay, do I know what direction this will be opening? And to do so, all I need to do is look at that value for A. And in this case, the value for A is -1. And so I know that this graph, I already know that this graph will be opening down. What I don't yet know is I don't yet know things like the y-intercept, the x-intercepts, the axis of symmetry, so on and so forth. If I wanted to figure out the y-intercept, we could do so really easily. We said that you can figure out the y-intercept whenever x is equal to 0. That's a really easy way of figuring out the y-intercept. If x is equal to 0, then we have 0x squared plus 2 times 0 would be 0 plus 8. And so very easily for us, we can quickly determine that y would in fact be 8. 1, 2, 3, 4, 5, 6, 7, 8, all the way up here. So we can actually map that 1 point already. We actually know what the y-intercept is. We know it's 0, comma, 8. If we wanted to figure out some more information about the x-intercept, well, that's going to take us actually another step. So what we can try to do here is we could try to figure out where the axis of symmetry was. And we could do so using a series of test points, and we could try to figure that out using that method. What we'll get into later is I'll show you that there is a much more efficient way of being able to graph, but also being able to figure out the x-intercepts. And so what we're going to do here is let's choose the point. Let's say when x is equal to 1. Let's try and figure out what this graph is equal to. Let's try and figure out the shape. So if x is equal to 1, this would be -1 squared, which would just be -1 times 1 squared, which would end up being just -1, plus 2 times 1 would be, we'd end up with 1 times 1 squared plus 2 times 1 plus 8. So we'd end up with -1 plus 2 plus 8. And when you do all of that, that ends up giving you a value of 9. So when x is 1, we know that the y value is 9. X is 1, y is 9. And so this looks kind of like, it looks like we're getting up close to what the top of this graph would be. It looks like we're getting close to where the vertex would be. We said that the points are going to get really, really close together when we get to the top of this top of the graph, and we know that it's going to open in the downward direction. So let's check when x is equal to 2. We have -1 times 2 squared plus 2 times 2 plus 8. So when we plug these values in, you get -1 times 4 plus 4 plus 8. In this case, we are going to end up with -4 plus 4 plus 8. And so what you end up determining then is that when x is equal to 2, y is going to be equal to 8. And whenever you see a point that looks like this, you know that we've actually found the vertex of the graph. And we found out that the vertex of the graph was right there. So we know that the axis of symmetry, and we can test points that go further than this too. Let's test when x is equal to 3. Let's test and see what we get for that. So negative 1 times 3 squared plus 2 times 3 plus 8. We're going to end up with negative 9 here plus 6 plus 8. And then we're going to end up with a y value of 5. So 1, 2, 3, 4, 5 right there. And again, because we know where this axis of symmetry is, which is right here, we will know then that, well, on the opposite side, this point will be mirrored. So we know that this point on the opposite side of this graph will be right here. And we can kind of see the start of the vertex already. We can sort of start to see where this graph actually looks like. And so what we know now is we know where the vertex is. We know that it is when x is equal to 1. And so we can say that the axis of symmetry is x is equal to 1. We can say that the vertex of this actual graph would be this point up here that I just put a circle around. And that point was when x is equal to 1 and y was equal to 9. So 1 comma 9. The maximum or the minimum, we know that the max of this graph, will be when y is equal to 9. And then the domain, well, the domain is always xer. The range is yer, and then y is going to be less than or equal to 9. So we know all of those parts about the graph already. And for us to figure out the x-intercept, we could try plugging in more values and see if, in fact, when we plug in a certain number, x is going to be equal to, or y is going to be equal to 0. So let's try plugging in a 4. So we have negative 1 times 4 squared plus 2 times 4 plus 8. And what we will find then is we'll find that this 4 squared is 16. So we'll have negative 16 plus 8 plus 8. That is equal to, oops, sorry, that was really sloppy. That is equal to 0. And so then we would know that at the point x is equal to 4, that's going to be equal to 0. And because we have this axis of symmetry, we know that that'll be repeated on the other side as well at x is equal to negative 2. So at negative 2, 0, and at 4 comma 0, we will have our x-intercepts. Now, this was a very, very lucky graph for us. This is a very lucky strategy of us calculating out, the x-intercepts. This is a very lucky strategy because, in fact, the x-intercept fell right on a point. But what if we get a graph? What if we get a graph where it doesn't fall exactly on the point? Well, then we are limited in what we're actually calculating by doing a table of values. And so what we'll see here is we can fill out a number of pieces of information based on what we just did. The direction of opening and shape of the parabola depends on the a value. And that was exactly similar to what we saw yesterday, that the a value would depend on both the width or the narrowness of the parabola, and it would also depend on what direction it opened. If you want to find the y-intercept, you plug in x is equal to 0. And when you do so in standard form, what you'll find is that y is always equal to 0 plus c, or y is just equal to c. So the y-intercept is always going to be the c value. To find the x-intercepts, plug in y is equal to 0 and solve for x. Now the issue with that is that when you plug in y is equal to 0, you end up with 0 is equal to ax squared plus bx plus c. And that is not an inherently easy equation to solve for. In order to solve for that, you'll actually need to factor. So you'll have to flash back to your grade 9 skills and we'll need to factor in order to solve for that. The equation of the axis of symmetry is always halfway between the x-intercepts. The equation for the axis of symmetry is halfway between the x-intercepts. And you can actually find that, axis of symmetry if you know the x-intercepts. And you can find that using the x-intercept 1 plus the x-intercept 2 and you could divide that by 2. That can be one of the equations that you use. So if we were to do that for this particular graph here, we would say we could find the axis of symmetry by saying x-intercept 1 has an x value of 4, 4, and the other x-intercept was -2. So we could do 4 plus -2 divided by 2, and when you do so, you end up with a positive 1, which was, in fact, right where our axis of symmetry was. It was right along x is equal to 1. And so we could solve for it using that method. To find the y value of the vertex, all you would do is plug in the x value, and you would plug that into the equation y is equal to ax squared plus bx plus c. You'd plug in that x value, and then you could solve for y once you have all the numbers plugged into that. So the goal here is we want to determine the x and y intercepts and the vertex for the following function. And so in order to determine the x-intercept, we need to do that first. We need to set y equal to 0. So we have 0 is equal to negative x squared plus 7x minus 10. Now, me personally, I don't like dealing with a negative x squared. To me, that just complicates the factoring. And so what I'm going to do is I'm going to divide this entire side by -1. And I'm also going to divide the other side by -1. Now, 0 divided by -1, well, that's just 0. So I haven't really changed anything. But what I have changed is then I will end up with x squared minus 7x plus 10. So all I've done here is I've just changed each of these signs to the other sign. So now I have a positive x squared minus 7x plus 10. And now I'm at the stage where I need to factor. And to do so, what I need to do is I need to figure out two numbers when multiplied that equal x squared. And I need to figure out two numbers when multiplied that equal positive 10. The only way that I can get an x squared, I'm going to set up my brackets here. The only way that I can get an x squared is if I have x times an x. So when we're foiling, we'll have to do x times x, and then we'll have to do x times the other thing. Well, the only way I can get an x squared is through this first blue arrow here, where I have x times an x. So I know that that's how this has to start. And then the other way that I can solve for this is I need to figure out two numbers that when multiplied will equal 10. And so that means I have two options. I have 10 times 1, or I have 2 times 5. And so then the last consideration that I have is I want those two numbers that I used to multiply to add to -7. So what that means then is I also have an expanded number of choices. I could also do -10 times -1, or I could also do -2 times -5. And when I do this, I want to look at these numbers and figure out which one of them is going to add up to -7. 10 plus 1 is 11, 2 plus 5 is 7, -10 plus -1 is -11, -2 plus -5, oh, that's -7. So in fact, this becomes our winner. And so then what we need to do is x minus 2 and x minus 5, and then that will give us our factored version of this above equation. That'll give us our factored version of this above equation. Now, the rule is that we need to try to get both of these brackets, or either one of those brackets, to equal 0. And so what you want to do is you want to set a goal of making either one of these brackets equal 0 by plugging in some number for x. So for this first one, I could plug in x is equal to 2, and that would give me an answer of 2 minus 2 is 0, and then 0 times whatever this bracket is, it doesn't matter, it's still 0. And then the other option I have is that x could be equal to 5. 5 minus 5 again is 0, and so that would make this equal to 0 statement true. So now I have two values of my x-intercepts. It can be either 2 or 5. And so the next step that I said was to take our equation, and our equation was y is equal to -x squared plus 7x minus 10, like such. And now what I want to do is I want to plug in either one of those two x values to figure out I want to figure out what my y-intercept is. But in order to get to this point here, what we have to do first is figure out the axis of symmetry. So I'm getting a little bit too far ahead of myself here. Let's just move this down a bit. We'll save that for later. If we want to figure out the axis of symmetry, what we will do is we will take x1 plus x2 and divide that by 2. And in this case, our two values for x were 2 and 5. So x1 is 2, x2 is 5, and we will divide that by 2. And when we do, we'll get an answer of 3.5. And so what that means is we want to plug in 3.5 for our x value, because in our graph, 3.5, 3.5, that would be our axis of symmetry. So when we come over to the equation, we'll say y is equal to negative 3.5 squared plus 7 times 3.5 minus 10. And when we do that, we end up getting an answer of y is equal to 2.25. And that would be our y-intercept. And so what we should be able to do then is we should be able to go to Desmos, and we have y is equal to negative x squared, and it was plus 7x minus 10, and we should be able to check and see where those x and y intercepts are. And so this is the point of my vertex here. Awesome. Okay, so what we want to be able to find is we know that the y point of our vertex would be 2.25 and 3.5. So our vertex should be at the point of 3.25, comma 2.25. Should be where our vertex is, based on the information we found out. And if you look right at the vertex, it is in fact 3.5, comma 2.25, which was exactly what we had solved for. And then in terms of figuring out our x-intercepts, we would expect intercepts at 2 and 5. We would expect x-intercepts at 2 and 5. And then the y-intercept, we would expect the y-intercept based on this to occur at negative 10. So we would expect the y-intercept to be equal to negative 10. And when we look at this graph, we can see that our y-intercept is in fact negative 10. Does anyone have any questions about that first example? We went into a lot of detail in that question to try and show all the different steps. The end goal of this, though, is you have to be able to factor and figure out what your x values will be when y is equal to 0. Once you have those two, you can use this axis of symmetry equation to figure out where the x value will be where the vertex occurs. So again, we figured out that this axis of symmetry would lie right along this point here. And as such, we then said, okay, when x is that, let's figure out what y is, and that will be the exact vertex. Okay. If no one has any other questions, let us keep going here. So example 2 says, sketch the graphs of the following quadratic functions in factored form and fill in the characteristics chart. So looking at this equation here, I know that my direction of opening here, I have a positive 2 for my a value, and so I know that this will open in the upwards direction. My y-intercept, again, that can be solved very easily when x is 0, y is equal to 6. So I know that my y-intercept here will be 1, 2, 3, 4, 5, 6. I know I'll have a point right there. The x-intercepts, that's the next stage that we want to solve. So we'll plug in y is equal to 2x squared minus 8x plus 6 in order to solve for the for the x-intercepts, we want to make y equal to 0. And now we have this interesting equation with 2x squared minus 8x plus 6. Again, I don't like numbers in front of my x squared. And so what I'm going to do is I'm going to divide everything here by 2. I'm going to divide everything on this side by 2. And I'm also going to divide 0 by 2. So I end up with 0 is equal to x squared minus 4x plus 3. That's the same step I did last time with the negative 1, but instead now I'm doing it with this 2. And so this looks a lot easier to factor. So now I know that I will have to have an x squared. So I'll have to have an x in the front of this, an x at the front of this one here in order to achieve my x squared. The next thing I need to consider is how can I achieve this 3 when multiplying two numbers together? Well, I could do 3 times 1, or I could do negative 3 times negative 1. Oops, that's a negative 3. Negative 3 times negative 1. And then the next consideration I want to make is which one of those two add up to my middle term, this negative 4. And it turns out it's negative 3 and negative 1. And so looking at these two brackets, I want to try and make either one of those brackets equal to 0. If I plug in x is equal to 3, I get 3 minus 3 is 0. Awesome. If I plug in x is equal to 1, 1 minus 1 is 0, meaning this entire equation is true. So our two x-intercepts then will be at 3 comma 0 and at 1 comma 0. I can figure out the axis of symmetry by going x2 or x1 plus x2 divided that by 2. So that would be 3 plus 1 divided by 2 should be 4 over 2. And so my axis of symmetry will be x is equal to 2. And so because I know when where my axis of symmetry is, because I know it will be at this point here of x is equal to 2, like such. Sorry. Draw this line. X is equal to 2. Then I want to figure out what y is when x is equal to 2. So I'll take my little equation that we have there, which is y is equal to 2x squared minus 8x plus 6, like such. And I will plug in y. I will plug in an x value of 2. And 2 squared is 4, which is 8, minus 8 times 2 is 16, plus 6. So that's 10. Y will be equal to negative 2 is the value that I have found there. Squared is 4 times 2 is 8. 16. 6. Awesome. So I know that my axis of symmetry occurred when x was equal to 2. And I just solved for my vertex there by saying that at 2 comma negative 2 is where my vertex will occur. In terms of the maximum or minimum, we will have a minimum because we know this is going in the upwards direction. So we expect it to look something like this, coming up like this from the graph. The other thing that I could use, just as a common sense thing to say, do I look like I'm doing this on the right track? Is I have a 2x squared here, and last time we said that if we have a number bigger than 1 in the value of our a, so if a is bigger than 1, our graph is going to be really skinny, and this is looking like a really, really skinny parabola, which means that yeah, I'm probably doing things right. I'm probably on the right track. So that's just my teacher brain, just checking to make sure, like, am I doing this okay? That's the skill that I have in order to check and say, yeah, I'm doing this right. So again, going back to our little data table here, we have a minimum value because we know this is opening up, and we know our minimum will be at y is equal to negative 2. Domain is always the same. It's always XER. The range will be YER, and y must be greater than or equal to negative 2. So the next step that we could take then is we could start plotting out some points. I'm going to use this axis of symmetry, and I know that this point will exist here. I could start plotting out some points as well then. I could plot out my x-intercepts, so I know there's one here at 1 comma 0 and one here at 3 comma 0. And then I can start to connect those dots like such, like that. And then we'll just confirm this in our little program here in Desmos. 2x squared minus 8x, I think it was plus 6. Plus 6, it was plus 6. Awesome. And you can see a graph that looks identical to ours. A y-intercept equal to 0 comma 6 there, like we had said. Y-intercept at 6. X-intercepts at 1 and 2. Something that starts down here for the vertex at 2 comma negative 2. So we can confirm that we have in fact drawn that one correctly. So that information is awesome for us. We can work in the opposite direction. So instead of being given a formula, we can actually be given a graph, and we can solve for that graph. Now, when you get graphs that look like this first one here, when I was looking at this earlier today, I was kind of thinking, like, what's the easiest way to teach this? What's the easiest way to explain this? Um, the difficulty with this particular graph is we don't actually know what the vertex is. So I can't say to you, graph it or write the formula out in vertex form first, and then go to standard form, like we will do in this second example here. Instead, the only points that we know really are we know this point here, and we know this point here. So we know that in both cases, when y is equal to 0, we know that we'll have x plus 7, and we'll have x plus 5. We know roughly that's what this graph will look like. We know that at the points negative 7 and at the points negative 5, we will have our two x-intercepts. And then what we don't know is we don't know what this y point will be here. But what we'll do is we'll pick a test point and we'll check to see if, in fact, when we plug the value in, it ends up working. So we'll pick that test point there. But what I would do is I would FOIL this out. So I'd go x times x times 5, and then I'd go 7 times x and 7 times 5. So what I'd end up with is x squared plus 5x plus 7x plus 35, and that's equal to 0. And then you could combine your like terms, and we'd have 0 is equal to x squared plus 12x plus 35, like that. And then instead of having it equal to 0, you could say that this was equal to y, because this was used to solve for the x-intercept. So what I'd want to do then is I'd want to try out this test point here, which is negative 3 comma 4, and I'd want to see if when I put in these x and y values, this statement is true. So my y value is 4. My x value is 3. So 3 squared plus, actually it's negative 3. Negative 3 squared plus negative 3 squared plus 12 times negative 3 plus 35. And let's see if that does in fact equal 4. So negative 3 squared will give me 9 plus 12 times negative 3 plus 35. And we find that 4 does not in fact equal 8. So what that means, what this means is that we probably chose the wrong x squared value here. It probably means that when we did this actual calculation, we were off by a factor of 2 from somewhere. And so then if we were to try and map this out, it would be a little bit tougher for us to go back and do this equation. So I'll show you what I mean with graphing vertex form when we do this second equation here. So this one presented a lot more difficulties because we don't actually know what the vertex is. When we do know what the vertex is, these graphs become a lot easier because we can graph it in vertex form. And if you'll remember, vertex form was y is equal to a times x minus p squared plus q. So we have the vertex here. We can go y is equal to a and then we can plug in a point here as well, and we can solve for a, and then we can eventually figure out this graph. So x minus, well, p in this case is 0, and y in this case was, for our vertex, was 9. And so we can solve this a little bit, and we can say y is equal to a x squared plus 9. We could plug in 2 points for x and y and then solve for a. So I'm going to choose this point right here, which is an x value of 2 and a y value of 5. So 2 squared plus 9. Subtract 9 from both sides. You end up with negative 4 is equal to a times 4. Divide both sides by 4, and you get a is equal to negative 1. And so then we could spit out the final formula for this by saying that our final formula is y is equal to negative 1 times x minus p was 0 squared plus 9. And then to get the final formula in standard form, we'd need to go y is equal to negative 1 times x squared plus 9. And we could find out that this graph is negative x squared plus 9. And that's the final answer for that one there. So again, doing it in vertex form is a little bit easier because we can actually do it in vertex form first, and then we can deviate to standard form. And so we could try that for this first one here. We could start from square one and try guessing what this vertex was. And let's say that this vertex was 0.5. Say that that vertex was at 0.5 for our y value and negative 6 for our x value. And so what we would do is we'd say y is equal to a times x minus a negative 6 squared plus 0.5. We could simplify this to y is equal to a times x plus 6 squared plus 0.5. And then what I would do is I would try to FOIL this out. And then I would actually solve for a here first, and then we'd have to FOIL it out. So let's choose the point. Let's choose an easy point here. Let's choose 0, negative 5. So y is equal to 0 is equal to a times negative 5 plus 6 squared plus 0.5. 0 is equal to a times 1 squared plus 0.5. And then what we would figure out here is we would subtract 0.5 from both. Subtract 0.5. And this should be, this should not be plus 0.5. This should be negative 0.5. So I need to change this. This should be minus 0.5. And so I'll add 0.5 to both sides, and we'd get 0.5 is equal to a. And so then what we would do is we would take that knowledge and we would plug that in here. We'd say y is equal to 0.5 times x minus 6 squared minus 0.5. And then to write this in standard form, we'd have to go y is equal to 0.5. I'd want to FOIL out this x minus 6, so I'd take x minus 6 times x minus 6 minus 0.5. Foiling this out, we would go x times x times 6, and then we'd go 6 times x and 6 times 6. And what we should get here is y is equal to 0.5 times x squared minus 6x minus 6x minus 36 minus 0.5. And then we'd have to multiply this 0.5 by each thing inside the brackets. And so I'm going to combine the two negative 6's into negative 12x into like terms. So we would get y is equal to 0.5 x squared minus 6x, because 0.5 times 12, half of 12 is 6. Half of 36 gives me 18. So I have minus 18 minus 0.5. And then I should get this final equation of 0.5x squared minus 6x minus 18.5. And that should be the final equation there. So again, going from vertex form into standard form requires a lot of steps in order for you to actually get there. Again, what we're doing is what we did yesterday in solving for A, that all of this first part here should not be new news to you. All this first part here is just us solving for A, trying to figure out what it is. The actual new stuff is all of this stuff that I will highlight here, all of this second part here, and all of uh, the second part here as well. Those are the new pieces of information where we are now plugging in what we know for A, plugging in what we know in terms of our P and Q value and trying to convert it into standard form. Does anyone have any questions, comments, concerns about that particular piece there?